Alright, hello everyone. This is lesson 18, and today we're going to talk about I/O ports and some of their functions. So, I/O ports. I/O stands for input and output. And then some other things that we might need to know. D stands for digital, and A stands for analog. So first, let's talk about the ports on here, which are on here. These are the pins that I will be talking about today, or the ports, if you will. So this is the digital. Digital pins are from 13 to 0. And then here are the power pins. And this is the analog pins for input. Alright. So D0 to D13, these pins can be used as digital inputs or outputs. So D0 to D13 is all of this, starting from 0 and all the way to 13, which is over here. All of these are digital, so D and then the number behind it. After that, we have some specific things. For example, D0, so digital 0, which is also known as the RX port, and the D1, which is called TX port. These two pins are used for serial communication. So for example, if we want to communicate to the serial monitor more effectively or something like that. So this is the D0 and D1 port, and if we look over here, it includes TX and RX here. Alright. After the digital pins, we can talk about the analog pins, which are over here, A0 to A5. So A0 to A5, these pins can be used as analog input and can read voltage values between 0 to 5 volts. So the difference between digital inputs and analog inputs, I think I went over this earlier, but digital inputs can only return 0 or 1 and can only output a 0 or 1. But analog input is the analog input is a float between 0 and 1, or in this case, in bits. For Uno boards, it's from 0 to 1023. So that's 10 bits. The analog input function of Arduino has 10 bits. So 10 to the power of 2, or 2 to the power of 10 is 1024. So what this means is that it can convert a 0 to 5 volt signal into an integer between 0 and 1023. For example, if it was exactly 5 volts, then this would output 1023. If it was 0 volts, then it would be 0, and so on. Alright, so these are the analog inputs. Next, let's talk about some of these power ports. First one is the VIN, which is this one right here, VIN. So VIN is the power supply pin used when connecting an external power source. And next, the 5 volts and 3 volts. So the 5 volts is over here, this one right here, and 3 volts is here. Alright. The 5 volt power output pin, this can be used to power external devices. And the same thing for the 3.3 volts. So normally we should either use 5 volts, sometimes we can use 3.3 volts as well. It depends on the device or what the module calls for. And next, besides these two, we should have a ground port. And if you notice, there's 2 ground ports. You can connect one to the 3.3 and one to the 5 volts. Think of this as kind of like the negative end of a battery, or like the negative end of a circuit or something like that. Alright, ground, which is GND stands for ground, by the way. It's the ground pin used to connect the circuit's ground line. Okay, so these are some of the pins that we are going to use today. Also, it should be noted that digital pins can be set to input or output mode, while the analog pins can only be used as inputs. In programming, you can use the Arduino programming language to read and control the status of these pins. So pins, alright. And then let's go over the digital and analog again. So the digital pins have standard logic levels that are either high or low. High level is represented by 1 and low level by 0. So what this means is that basically if there's 1, then that means there's power, and if it's 0, then it means there's no power or really low power, and it won't be enough to power whatever it is that needs powering, be it a device or a module or anything that requires energy. And then we talked about how analog pins can be used as, so analog pins are, all of these pins are analog pins, and these are all digital pins, and then these are analog pins. So I said all the digital pins can either be output or input, but the analog pins, as you see here, can only be inputs. So how do we do outputs for analog? If we see here, it says PWM, and this is a squiggly line, by the way. So anything with this means it's PWM. If we look here, which is the 3, the 5, the 6, the 9, the 10, and the 11. These can all do analog outputs if you define it as such. Alright, PWM pins can be used for analog output, but cannot be used for analog input. PWM stands for pulse width moderation. On the Arduino Uno board, the PWM pins are 3, 5, 6, 9, 10, and 11. PWM pins can also be used for digital input and output. So the PWM pins are the most versatile of all of the pins. The only thing it can't do is analog input, which would then require the analog pins to do. Specify again that analog pins cannot be used for analog output. Cannot. And specify which pins, A0 to A5. Okay, so these, I've introduced most of the I/O ports. Quick recap. These are the digital pins, and these are the analog pins. To have digital input or output, you can use any of these pins from 0 to 13. But for analog output, you can only use the ones with the squiggly lines. So 3, 5, 6, 9, 10, and 11. They're called pulse width modulators. And for analog input, you can only use these. And power is supplied by either the 5 volt or the 3.3 volt and goes back into the ground. Alright, next let's talk about functions. So how do we set up for the use of these ports, and how do we define if the ports should be output, input, analog, or what? So the first function is the pin mode. So it has two parameters, a pin and a mode. The pin mode function requires two parameters. The pin parameter determines the pin number to set. The mode parameter determines whether the pin operates in input or output. There are two values for interface mode setting. It can either be input, which is to set an interface for normal input mode, and output, which is to set an interface for output mode. An example of this is pin mode A4, which is analog 4, and then input. Remember, input and output has to be all capitals, and the pin mode function is normally called or used in the setup and not the loop. Next, we have digital read. It only has one parameter. The digital read function requires one parameter. The pin parameter determines the digital interface number to read. For example, first define the mode. For example, 7 is input, and then we can read from it. And if it's not specified whether it's digital or analog, then the computer will always assume that it's digital. Digital read 7, and this means it will read the port of 7 and see if it's 0 or 1, since this is digital. And then after digital read, we have digital write. This needs a pin and a value. The digital write function requires two parameters. The pin parameter determines the digital interface number to write. The value parameter determines what the pin writes. There are two values, and what the two values are, it can either be high, set the output to a high level, so basically give power out, or low. This sets the output to a low level, so basically it stops giving out power. An example is, for example, pin mode 2, the second port, is output right now, and we write a 2 high, and this means that it is giving out energy from the second port. Alright, after digital write, we have analog read. So like digital read, analog read only needs one parameter, which is the pin. The pin parameter reads the input voltage between 0 and 5 and converts it to a value between 0 and 1023. So this is 10 bits. Again, I think I explained this already. For example, pin mode, analog 2, input, and then analog read, A2. And this would return a value somewhere between 0 and 1023. And this reads it between 0 and 5, so of course it gets converted. And I'm sure you guys can guess what the last function is. We have digital read as opposed to analog read, and we have digital write as opposed to analog write. Analog write. Again, this needs two parameters. The analog write function requires two parameters. The pin parameter determines the analog interface number to write. The value parameter determines what the pin writes. The range of the value parameter is 0 to 255, which is 8 bits. Now this is very important. While the input can be from 0 to 1023, the output only goes to 255. Well, that is very, very important. So if you read something and then write it out, it could be higher than this. So you need to either do a map or some other function to translate the number into 8 bits. Alright, now that we finished all the functions, let's do a few examples. Example 1, lighting and LED. I think we went over these somewhat before, but I will go through them again. So I made a breadboard picture using fritzing like this. Okay, let's crop this a little. Right? Oh shoot, that is not cropping. Alright, that's better. And then we can rotate this. How do we rotate? Image. Rotate like that. Yeah, that looks very much better. So we're gonna build this circuit out. So 5 volts and ground with using PWM port 3. We bring the line here using a resistor, 220 ohms, a light bulb, and back to the ground. Yeah. So let's build this. Alright, we have a breadboard here, over here, and then, okay, so let's see, ground is this one here. We can plug this in here, and then the positive 5 volts comes in here. We can plug it into the 5 volts. Alright, and then we add a resistor of 220. So let's do this. 220, and then one end was connected to the ground, so oh wait, we also need an LED. Can't forget LEDs. Like this. Which end was positive? This end was positive. Alright. And then we can connect this end to the ground. Like this. This is connected to the ground through this wire and comes back out. And then we can connect this end to PWM port digital 3. So it would be this one right here. 0, 1, 2, 3 here. Like so. Alright. Now the hardware is done. As you can see, it comes out through here and then goes through the resistor, through the LED, into this, which brings it to the ground. We didn't really need the 5 volts for this, but it's alright. And now we can come into our Arduino IDE, and then we can write the code. So we use pin mode to define port 3 as output. And then here, digital write to show that we don't want an analog write, but rather digital, so either 0 or 1, low or high. So digital write, number 3, and high. Alright, don't forget the semicolon here. Okay, now let's run this and then watch the oh, I forgot to plug it in. I'm sorry. Alright, now that it's plugged in, you should be able to see it light up like this. Wow, yes, very bright. But now the LED is lit up. Okay, so this is the first example. Very simple, just 2 lines of code, or 4 if you count the setup and loop. Okay, example 2, let's go back into here. Oh yeah, let's copy the code. Example. Okay, so example 2 now. Example 2 is button activated LED. So instead of the LED being active all the time, now we require a button to activate it. Make this heading 2. So the diagram for the breadboard would be like this. This part is still the same. You still need something here and then a button here. Now the button just gives an input back, so we can determine whether this should be high or low. And here we use a very classical pull-up resistor type of diagram. So power comes in through number 12, and then if the button is not pressed, it goes through this resistor, comes here. Oh no, sorry, the power comes in through 5 volts. This is the input for the Arduino. So the 5 volts comes in, goes through here, and goes through the resistor. And if the button is not pressed, it goes through number 12 into here. And so if it's not pressed, it would be 1. and when it is pressed, it becomes 0. And that's because in each port there's a little bit of resistance, and so if it's going to ground, it would have less resistance. So when the button is pressed, the electricity goes through the ground. So when the button is pressed, it becomes 0, and if it's not pressed, it's 1. So let's build this. Alright, we can just add on to what we have before. Let's add a button. This is a button like this. Alright, and then we can add, let's say, this white line from this button to number 12. Number 12 would be this one, I believe. Yes. Oh. 8, 9, 10, 11, 12. This one. So it would be 12. Wait, let's go under the blue line. Blue line is too long. 12 is this one. Alright. And then give it power through this. 5 volts of battery. Like so. Let's get a 10K resistor, which is this one. And let's connect this to let's connect to here, let's say, and we need to move this up 1 into here, and now it goes through the resistor and either goes back through here or goes to the ground using this line. If the button is pressed, it would be able to go through, yes, and then to the ground, which is over here. Alright, like so. So energy or battery or power is coming out from here into here, and it uses this red line here, goes through this resistor here, and either goes back up through the white line, or if the button is pressed, it uses the black line and goes through the ground. So this is our breadboard view. And then now let's go into our code. Alright, so 3 is still output, we still need it for the LED. And then now we can define a port 12 for input. That's about it. And then we no longer need this line. We can do an if statement. If digital read 12. So if the button is pressed, it would be 0, and if it's not pressed, it would be 1. So if this is 0, which means if it is pressed, then we can turn the light on or off. It depends on what it was before. So we need another variable. Let's say a boolean called state. And now the state is the opposite of what it was before. And then we can update the port 3. So digital write 3 and then state. So if it was on at the start, so if state equaled 1 or true, and then this was pressed, state became the opposite, so it became 0, and then it was updated, then this would be 0, and then the LED would be turned off. And then let's add a line so that if you hold the LED, it does nothing. It doesn't flicker on and off really fast. That's what this line is for. And then the delay, but before and after the the while loop is for the static. So when you press the button, it's not a perfect on and off. There's a time in between that is on and off at the same time, and that's about 20 milliseconds. So like this. This should work. Let's not forget the semicolon here. Alright, now let's run this. And then show, oh, I forgot to, oh wow, keep on forgetting to connect the Uno board today. Alright, now it's uploaded. We can see here, if I come here and press the button, it will turn on. The light will turn on, and if I press it again, it turns off. If I hold, let go, oh, yeah, so like this. Yes, alright. This is example 2. Let's disconnect this. It's a good practice to disconnect the power while we're messing with the circuit and everything. Let's include this into our code. Okay, now we're on example 3, which is a breathing LED. This uses the same layout on the breadboard as the first experiment, like this. Let's crop this again. And we can rotate the image like this, I think. Yeah. Like this. And then what we want is for the LED to turn on slowly and then turn off slowly. Turn on slowly and turn off slowly. Kind of like breathing. Deep breaths in and out like that. So we just slowly make the output for 3 higher until it's max, and then lower until it's 0 again. So on here, we no longer need this whole thing for the button. We can take out the button now. And we don't need this resistor for the button. Or this. And I don't believe we need for number 12 anymore. Yeah, and this should be all that we need. Now let's get into the code. So the code for this should be simple. We no longer need this or the state. We just need a loop that loops to the from 0 to 255 over and over again. So in the loop, we can do another loop. Oh, I forgot this. Alright. For integer I equals 0, I is less than 255. We iterate it. We can do analog write 3i. Write 3i. And then we can wait for a few seconds, or 15 milliseconds. So if we don't wait, then it would just turn on almost instantly because it goes through the loop very, very fast. Alright, so let's run this and try it out. Like this. Oh, device manager, sorry. So now we can see that it's, oh, we only did the breathe in, we forgot the breathe out portion of the breathing LED. So we can make another one. Integer I equals 255. I is then 0, I minus minus, and then analog write 3i, oh, 3i, and then delay 15 seconds, like this. So 255. Oh, this should be greater than, not less than. Alright, like this. Now this should work. So now let's breathe in. And breathe out. Breathe in and breathe out. Alright, so this is correct. We can make it look better. I think 255 and like 125 doesn't make a difference. So let's change this to like 60, 64, 63. And let's change this to 64. Now it should be more obvious. Breathe in. Oh, now it's a little too fast. Let's make this a little slower. 20 should be good. Make this, let's say 25. Alright. Now let's breathe in, breathe out, breathe in, breathe out, breathe in, breathe out. Now it's pretty good. Alright, so this is the code for the experiment 3, breathing LED. Let's copy the code in there. Code in here. Alright, next, example 4, which is measuring a potentiometer. So a potentiometer is basically like a resistance, but you can change how much resistance is in the resistor. So what I'll be using today is this right here. This right here. You can turn it either clockwise or counterclockwise like this. So if you turn it clockwise, I believe it's less resistance, and counterclockwise is more resistance. It has 3 pins. These 2 at the end can either be 5 volts or ground. They're interchangeable. And the middle one measures how much resistance is in the resistor. So on the breadboard, we would need something like this. I'll make this a 2. Something like this. Oh, disregard the LED section. That's for experiment 5. I forgot to make a fritzing image for example 4, I'm sorry. So the battery power comes in through here and comes out through the ground, and the blue line is able to measure how much resistance is in it. And we will be able to see how much is in it through printing out the values, both the actual value from 0 to 1023 and a calculated voltage. So here we need to print, so serial.begin is needed, 9600. And then we need an analog input pin, so let's use A0 input, and then in here we can make a variable integer sensor value, analog read A0, and then we can turn the number into a voltage, and it might need decimal points, so let's use a float. Voltage equals sensor value multiplied by 5.0. Remember to add the 0.0 because we are calculating for float. 0.0 like this. So this converts the 0 to 1023 value into a voltage from 0 to 5. And then we can print out both sensor value and voltage. So serial.print sensor value, and then serial.print. This is a tab, and then voltage. and we can print the voltage amount here. Alright, this should be it. Now let's watch as I change this up. We don't need the LED anymore. Let's put these to the side for now, like this. And then we can add our potentiometer on here. Let's add it in. And then one side is connected to the positive terminal. So let's say this one is positive, and then this one is negative. From here into here, like this. Okay, let's move these two back a little. So into here and here, like this. And then we need another line, let's say this white line, to go in the middle pin and into used a 0 here. Alright, so we put it onto analog 0 port, like here. Alright, now we can plug this in and run our code. Oh, did I spell something wrong? Sensor value, like this. Alright, now we can open our serial monitor. Alright, look, so now when I turn this, right now it's at max. If I turn this clockwise, the voltage goes down, and so does the sensor value. So now it's at the end, but not 0. If we go to the middle, for example, 2.5 volts, 2.5, like this, it should be 512 or 511. Somewhere here. Yeah, it's kind of fun playing with this and seeing the numbers change. Alright, so this is experiment 4 or example 4. Alright, now the last one. Let's get rid of this. Now we have the last example, example 5. So controlling an LED through a potentiometer. So what we want to do is, let's copy this image. So what we want is, if we turn this all the way, then this light lights up all the way. And if we make the resistance too much, or too little, I mean, if the value is 0, then this light turns off. So let's change up our breadboard. Oh, I should have just kept the LED on there. Why did I take it off? So let's add our LED, add our resistor in here, and then LED in here. One end goes into the ground, like here, like so, and the other end is connected to our very special pin number 3. Pin 3, like this. So now the value for the potentiometer goes in through the white line, and then some processes go on in the Uno board, and then through the blue line it comes back in here and turns on the LED depending on the value. So let's make this a reality with our code. We no longer need any of this. we will need a pin for 3, pin mode number 3, output. Alright, and in the loop we can simply, I should have kept the sensor value line in, equals analog read A0, and then we can do an LED value. So since the analog input is 0 to 1023 and the output can only go up to 255, then we need to convert it into something less. So we can use the really handy function map. I don't remember, I believe I taught this one in this course. So we can do sensor value. So we want the value in here, which is originally from 0 to 1023 to 0 to 255. So this number line gets shrunken down to this, it gets compressed, and all the values get compressed alongside it. So now we converted it, we can write it using our third into the LED value. Like so. I believe this should work. Let's try it out. Oh, wow, I keep on forgetting to plug it in today. Like this. Alright, now let's try it out. This doesn't work. Maybe something went wrong along the way. Let's check it out. So this is connected to here, that's correct. Is this positive? Yes, this is positive. Goes to the ground. Why is this wrong? I have no idea. Did I plug this into the wrong one? This is 3, I believe, yes. Maybe it didn't upload properly? Oh, of course I forget again. Okay, let's get it to print our value for sensor value again to make sure that part is working. Alright, after trying to debug it, apparently port 3 was plugged in incorrectly. Alright, now this should work. So let's see. Like this. And then when I turn it back down, Why does it still not work? Oh shoot, I changed this. Alright, let's turn this back into LED value. Alright, now it should work. So now, currently it's, then I can turn it on, and then I can turn it off. Turn it on, and I can turn it off. Yeah. Alright, so this is experiment 5 or lesson 5. And I forgot to make this a header. Alright, and let's include our code into this. Like this. Alright, and then lastly, let's talk about the homework. So I've been working with the red LED, right? And of course it doesn't make a difference, but you can try to recreate the breathing LED I showcased, but choose a green LED. So now it's variety and it'll look cooler. Alright, thank you for watching.